So today we're going to look at a practice version of your performance task. So today, the practice version of the performance task, and you've got a link to this, takes us to a little lab activity. I get to do some physics. We're going to look at a mass on a spring. Okay, your activity when you do it won't be a mass on a spring. It'll be something else to click on or something else to do. But today, for this practice version, we're going to do masses on a spring. Great. So what do? This is like a little lab. You're going to go to the lab part. If you're doing this along with me, you're going to grab the orange. You need a ruler. We need a timer. I need stuff to go slow, and to start, I'm going to have it paused. Okay, I'm just kind of following the instructions that I gave here. When we do this as a performance activity in a class, I'll actually go through whatever the task is with you to make sure you know what you got to click on or what you got to do. So the way this is going to work is I'm going to squish my spring really, really small. And just so you know, if I put something heavy on a spring and I go normal speed, it bounces up and down. And so what we're going to do is take some data about how long the guy has been bouncing versus how many centimeters it has moved. Okay, so let's reset this. And so the idea is, now that everything's all set up here, I'm going to go slow because I have no reaction time. I'm ready to collect some data. You're going to press play, and as the mass moves, we're going to write down the time and the length. So I'm going to hit play. Oops, I got to play on here too. I'm going to hit play and pause. And after 0.09 seconds, I think the mass is at about 14. 9 seconds, it's at 14. Great. Play, pause. At about 15 seconds, we're at, I'm going to call it 32. 15, length is 32. When we do this as a class during the activity, I'm definitely going to go slower than this. If you really want to do this activity, you're welcome to. Did I say 32? Doesn't really matter. 26 and 70. 26 and 70. And my last data point will be 30 and 85. All right, so you're going to collect some data. Wonderful. Let's make this nice and big. Can't go bigger? Okay. All right, so this beginning part is going to look different for your actual performance task. This part is going to be the same. Okay, literally same instruction. We're going to create a scatter plot of your data. You can do this by printing this out on paper and drawing dots. You can copy and paste this image. You can use whatever graphing tools you like. I am obviously going to use my beloved Desmos. So here's Desmos. What am I graphing? Oops. And so it's already, the link here actually enters it in with the ability to draw a straight line. You're welcome to use that or not as you wish. All right, so I need a chart that looks like this. So right here, if you're in a complete blank spot, that's okay too. You can go to the plus and add in a table. So I'm going to add in 9, 15, 26, and 30. Oops, 21, 26, and 30. So I can see the first couple data points okay, but I'm going to have to zoom out to be able to see my other ones. And when I just scroll with my wheel, I need it to change this. I've got enough height here, but I've got too much wasted space sideways. I'm going to use my graphing tools. I want my x-axis to go from, I don't know, 0-ish to 30-ish. I'm going to say negative 10 to 50 or something like that, maybe 40. And I want my y numbers to go a little bit below 0, negative 10, oops, to like 100. And now I've got some reasonable data points. Okay, you can play with the zoom whatever way you like. Okay, but we definitely need to graph our points. At this point, you could take a screen grab so that we can work with it. so we've created a scatter plot from your data using Desmos. You can either just copy and paste this in. Since we're going to, as our next step, draw a straight line, you can use whatever editor you want. This box is actually editable. So if you click on the image that's here, and you'll have the same image on your real version of this assignment, you can click Edit, and it'll open up Google's drawing tools, which are quite limited, but enough to get this done. You can draw your own graph from scratch, or you can delete what's here and paste in your Google one, your Desmos one, excuse me. You want to make sure that you have your axes labeled. So our bottom axis in this case was time. I'm going to get a graph, time in centiseconds in this case, and the y-axis was length or location in centimeters. Oops. Okay, so you want your x-axis and your y-axis labeled. I'll move you over here. Wonderful. Okay, and so you can save and close, and now that's your graph here. So add a scatter plot, include appropriate axis labels. Done. Draw a straight line on your graph that represents this pattern, and find the equation of that line. All right, so I'm going to again go to Edit, same one. I'm going to use the line tool and draw a line as best I can. Okay, it's not going to be perfect. You can use the dot tool to wiggle it around, something along those lines. I can live with that. I'm going to make it a color so that while I talk about it, it'll make sense. Let's do blue, maybe even a dashed line. Yeah, I can live with that. Okay, maybe thicker. Okay, so whatever it is that you like. Ooh, that's way too thick. Okay, there I've got a line. Wonderful. To be able to do something like find the equation of the line, I need two things. I need my slope, and I need my y-intercept. And now that I'm seeing this graph, I can see that my y-intercept goes lower than I'd like it to, doesn't it? So I kind of have a choice here. I can go back to my original graph here, and I can try to zoom out just a little bit so that I can see where my y-intercept is going to be. And now I take a screenshot this way so I have a big enough thing. That will make my life easier. And let's do this. Edit one more time. Take this out. Put this back in. Move this order to the back. Alright, so adjust my line so that I'm still happy. I would say it's about here. What do we think? Good. And my axes labels are still here. Wonderful. Alright, so my x-intercept I can see. My x-intercept, I've got it at about -20. Wonderful. Sorry, y-intercept. Why I'm saying x-intercept, I apologize. My y-intercept is -20. My slope. So when I'm doing slope, I need to find 2 points, and I need to find my rise and my run. I'm going to draw it on here. I encourage you to do the same to show your work, but technically, as long as you get a good idea and I know how you're doing it, you're fine. If I use this point right here as one of my 2 points, so I got to find 2 points on the line. And I'm going to find another point on the line. I'm looking for where the grid is nice. That's not bad. Take there. How do I go from one to another? Let's see. Let's use a different color this time. Line, please. I'm going to go up. And I'm going to go over. So when I'm looking over here, I start at, and you got to be careful with your numbers. This is counting by fives this time, 5, 10, 15, 20. So this is at 5, and it goes all the way up to 35. So if each box is worth 5, 5, 10, 15, 20, 25, 30, 35, 40. So this is actually up 40. I know it's less boxes, but each box is worth 5. Going sideways, what are we counting by here? I think we're counting by 2s. 2, 4, 6, 8, 10. So starting here, 2, 4, 6, 8, 10, 12. And I go right 12. There we go. So that will help me with my slope. When I'm typing on here, it's nice to insert an actual equation. Slope is going to be rise over run. Oops, come on. Okay, fine. I guess I gotta choose the fraction button first. Rise over run. Which equals, in this case, rise is 40. And the run is 12. And so that will be, if I do that in lowest terms, 20 over 6, drops it a little bit. I can divide them both by 2. That's still not lowest terms. How about 10 over 3? All right. And now that I have my slope and my y-intercept, I can find my equation of the line. So in general, let's use a new equation. Y is equal to mx plus b. I now know y is equal to my slope. (10 over 3) x minus 20. You know what the really cool thing about this is? Since you graphed it on Desmos, you can check your work. Y equals negative 10x minus 20. In my graph, oops, not this graph, this one. So over here, y equals 10 over 3x minus 20. Yeah, that's the line I drew. I'm happy with that. Woo! Yay me. Okay. What's the rate of change in this situation? How can you tell? What does it represent? That's your slope. You already did this. Okay. So how did you find your slope? I found the rate of change with a slope triangle. It is 10 over 3. Now what does it represent? The rise is the length of the spring, 10 centimeters. And the run is the time. It's how long it takes it to move in centiseconds. So it's length over time. It means the spring moves 10 centimeters every 3 seconds, centiseconds, fractions of a second. Okay, what does the slope mean in this case? What does the rate of change mean? It almost always relates the y-axis and the x-axis. How much is it changing per, often time, but sometimes other things? Okay. Using the line, can you make some predictions? What's the length of the stretch string at about 15 centiseconds? I'm just going to do one of these ones. All right, so at 15, let's see. I want to know what's the length at 15. So where is 15? 15 is right here. Oh, I actually took a measurement pretty close. Right here. 20, 25, 30. I would estimate this to be at about 32. Is around here. What do you think? 32? Maybe a little higher, maybe 33. There's where 15 is. Save. At 15 centiseconds, the spring has a length of 33 centimeters. I found the time on the x-axis and read the length from the y-axis. Okay. There's one other question I'm going to assign, but I'm not actually going to do that one for our little preview one. I'll leave that for you to take a look at. I hope that was helpful. I hope that's reassuring. Legit, the task for the performance task is take a very quick activity to get 5 numbers, 10 numbers I guess if you count the time and the thing. Use whatever you like to graph it. Find the y equals mx plus b. Answer a couple of questions with the y equals mx plus b. Hand it in. Okay, open notebook. You can use whatever resources you like. If you need anything during the task, reach out. In terms of the actual activity, I'm not telling you what it is, but we'll do it together in the first 10 minutes of whatever the assigned day is.